We classified warehouses according to their position in the supply chain. In this video, we are going to classify warehouses according to the dominant task that they are designed to do. And before I get into this dominant class or dominant purpose based classification, let me give you some three basic principles which could help us understand these objectives better. So, the first principle is very simple. Inventory is expensive, and so for the given service level, so every warehouse has to decide, well, we are going to have 98% service levels, 99% service levels, 99.95% service levels, and then accordingly, given those service levels, they try to minimize the inventory by various means so that that service levels can be attained. So principle number one is, since inventory is expensive, for a given service level, we must try to minimize the inventory that we can create and yet deliver the service levels that are required. The second principle is the principle of risk pooling. Now, what it says here, let's assume I have 20 retail stores and each of them are storing their own safety stock. Well, in that case, they would have to store substantially higher amount of goods as safety stock. But instead of those 10 retailers storing their own safety stocks, if I can create a warehouse in the same city and the warehouses pull the material from that single warehouse in the city, in that case, the warehouses, the variabilities from different type of retail stores would sort of aggregate and nullify to some extent at the warehouse, and so the inventory that the warehouse has to store would be substantially lesser. So creating this pooling warehouse or risk pooling warehouse closer to the destinations, destination warehouses or destination retail stores, which generally reduces the amount of safety stock required for a given level of service at these destination warehouses. And so risk pooling helps us substantially reduce inventory. And the third principle is the standard idea that, well, given the same ton movement, larger truck would have lower cost per ton miles. Now, not a very difficult principle to imagine, because what happens is, whether it's a small truck or a large truck, we still would need one driver. We would still need the same procedures. And the larger trucks have larger engines which are substantially more efficient in their fuel usage as compared to smaller trucks. So what happens is, given our requirement of distance, if you could transfer that distance in a larger truck as compared to a smaller truck, our cost per ton per mile would be substantially lesser. Now that we have understand these three principles, let's try and see how the different purposes of warehouse and how these principles are specifically applied. Consider this first situation where I have the green is the destination and the blue are the sources. So let's say I have three sources who need to supply some material to a single retailer. Now, in that case, all of these sources would have to send individual trucks to the retailer. So now the sources or the blue things have two options. One is send large trucks to the retailer so that they can save on transportation cost. Remember principle number three, larger trucks would have substantially cheaper than smaller trucks. But the problem of sending larger trucks is, when I send larger trucks, I'm saying a lot of inventory at one time. And so since I'm sending a lot of inventory at one time, the cost of inventory at the retail store goes up. An alternative is to maybe send smaller trucks. Well, wonderful. I reduce my inventory by sending smaller trucks. But what it does is that it substantially could increase my transportation cost, because now I'm using smaller trucks. So an alternative to this is to use what we call as consolidation warehouses. Consolidation warehouses are generally closer to sources. And what consolidation warehouses do is, I use smaller trucks and send goods to consolidation warehouses in smaller trucks from individual sources. And then I aggregate those material at the consolidation center and send those goods by a larger truck at the retail store. So retail store does not receive three shipments. They receive one shipment, one truck with three different type of goods in this scenario. And there is not high inventory of any one type of good. And since we are using a larger truck for a substantial part of our dispatch, we can reduce the cost associated with transportation. Um, Consolidation warehouses are typically used where we order many materials from one market. So let's suppose there is a city where I have many suppliers. A good thing to do is, instead of each supplier having to supply to me individually, we could use some kind of consolidation services, and use that consolidated services, put them at one location and then bring the goods to us. Many times when we move houses, the LTL service providers also do consolidation services. So this is the idea of consolidation. The second idea is what we have is the opposite idea of consolidation, which we call as break bulk. Now it's a very similar idea. Option one is when I have multiple retailers receiving goods from one factory or one RDC or one CDC. The RDC has to send full trucks to each of the retailers. The retailers' inventory could go up substantially, or if they want to reduce inventory, use smaller trucks, so transportation cost goes up. Now, to prevent both of these, what you could do is put a break bulk warehouse close to the city. So the goods would be shipped in bulk to the city, and then they would be broken into some smaller components and sent into smaller vehicles at the individual retailers. And that is why what you see, most of these retail chains would have a warehouse closer to the city. So if a retail chain has 5, 10 stores or 20 stores in a region, these 20 stores would generally be served by a break bulk warehouse, because it helps substantially reduce inventory as well as increase reduce my transportation cost. Third is this combination of break bulk and consolidation, which we call as mixing centers. Again, the principle, I think I'm sure you guys understand the way this works. They do both tasks. So instead of having these multiple deliveries from each warehouse to, or each source to each destination, now I can virtually put a warehouse in the middle. So as you can see in these paths or the lines that are created, the number of movement or the number of open lanes has reduced, and that makes the supply chain substantially less complex. A specific version of the mixing center is what we would call as crossdocks. Now, to understand crossdocks better, we should first understand what a traditional warehouse does and how does it look like. So a traditional warehouse would have this 4-step process where step 1, the goods would be received. Step 2, the goods would be put some location. As soon as I get a dispatch order for the goods, I pick up the goods and I dispatch it to the customer that intends to receive the good. This is a very traditional operation in a warehouse, and we'll see details of each of these processes in the later videos. A cross-dock warehouse turns this around by saying that, hey, there are no put and pick steps at all. So what it does is, as soon as the goods are received, they are identified immediately that, hey, this carton or this case or this each item is destined for this store or this CDC or RDC or whatever. And then immediately the goods are sorted and redirected to the location which is associated for that store or that warehouse. And because this cross-docking, what it does, it's super automated. The sorting machines are super automated, super quick. You use systems like put to light, pick to light, or whatever. And then as soon as they're redistributed, when the weight at the storage facility for, let's say, retailer 1 or retailer 2 goes above a threshold, well, we have a truck and it dispatches the material to that respective store. So as we see here, we did not have a put and a pick stage at all. It is sorted at the destination's location, and then automated sorting, and then whenever the goods reach the threshold weight, they're automatically dispatched to the destination. As you can see, the movement of goods in a cross-dock facility is very fast. It's way faster. The inventory levels are kept as much lower because goods are not being stored at all. But the negative is you cannot run a cross-dock facility without technology. So one, you would need material handling technology so that the material is resorted automatically and fast. And 2, you need some software technology also, so that as soon as the goods come in, even before they come into the warehouse, they are clearly identified that, well, this carton or this pallet or this each is destined for store number 37. This pallet is destined for store number 32. And this level of identification is actually what makes operating and creating cross-dock warehouses very difficult and very expensive. So we have seen 2 types of location or classification of warehouses depending on the location of where they are, and also according to the purpose that they serve in the supply chain. In the next video, we will see some other type of warehouses and finish this topic of the classification of warehouses.